Hello friends, this video on some natural phenomena part 5 is brought to you by examfear.com. No more fear from exam. So now the question is, how do we charge objects? Now there are very different ways by which objects can be charged. One common way of charging objects is by friction. But an interesting thing to note here is that only insulators, that is poor conductors, can be charged by rubbing. Now what happens during rubbing and why is it that only insulators can be charged by rubbing? So let us have a look at the process. Now when we rub two objects, there is transfer of electrons which is taking place. So let us take the example of this plastic comb. So here this is a plastic comb. Now plastic is a poor conductor of electricity, or you can say an insulator. So when you rub this plastic comb on your hair, what happens? Due to the rubbing of the comb or the plastic and the hair, there is a transfer of charge. So the electrons get transferred from the hair into the comb, and that is how the comb gets electrically charged. So that is how the comb gets charged. And once the comb gets electrically charged and you bring it near small bits of paper which are neutral, so what happens? These bits of paper, they tend to get attracted towards the comb. So that is how we see that insulators can get charged by simple rubbing, because during rubbing there is transfer of charge which is taking place, and due to transfer of charge an object can get electrically charged, because if the object is receiving extra electrons it will become negatively charged. If the object is losing out some electrons, then it will become positively charged. But in either of the cases the object gets electrically charged. Now that is what we are going to discuss now. No charging by rubbing in case of conductors. So here take a towel and take a metal key. So key is made up of metal, and metals are good conductors, right? So metals are good conductors, so they allow charges to flow through them. Now you take this key and what you do? You rub it on the towel. Now we had performed a similar experiment with a balloon. We took a balloon and we rubbed the balloon on a towel for some time, and then when we took the balloon near the wall, the balloon had stuck to the wall. But in this case, when you take the key near the wall, the key doesn't stick to the wall. The key falls back. So there is no attraction between the key and the wall. Why? Because this key is not electrically charged. And why is it not charged? Because it is made up of metal, which is a good conductor. And what happens in case of a good conductor? In case of a good conductor, they allow easy passage of electricity through them. That is, they allow flow of charges through them. Now these good conductors, they also have free mobile electrons. So these mobile electrons act as the charge carriers. So good conductors, they allow flow of charges or flow of electricity through them. So as a result, what happens is whatever charge comes into the metal, so that charge gets distributed all over the surface. But on the other hand, in case of insulators, whatever charge comes to the insulator, they stay at the same point. So the charges are static in case of insulator because they cannot flow through the insulator. But in case of conductor, since the charges can flow through the conductor, so the excess charges disappear because they flow through the conductor. As a result, there is a momentary current which passes to the earth through the conductor. So conductor basically acts as a path for the flow of charges. So all the charges flow through the conductor, so there is no excess charge present on the conductor. If there are no excess charge present, obviously then that object is not charged. That is what we learned, right? If an object has to be positively charged, there has to be some excess positive charges. If an object is negatively charged, then there has to be some excess negatively charged electrons. But if the charges are just flowing through the conductor, that means there are no excess charge remaining on the conductor, and therefore the conductor is not electrically charged. So this is why we cannot charge conductors by rubbing. So this is something very interesting and important as well. This means that you cannot charge every object by rubbing. It is only the insulators which can be charged by rubbing. So let us look at some more examples of charge transfer, where we can see that charges are getting transferred from one object to another. So let us look at one of the very common examples of charge transfer. That is the rubbing between a glass rod and silk cloth. So if you take a glass rod and silk cloth and if you rub them against each other, what is observed? It is observed that both of them get electrically charged. So the glass rod becomes positively charged and the silk cloth becomes negatively charged. So what does this mean? The transfer of electrons took place from the glass rod to the silk cloth. So electrons were transferred from glass rod to silk. So therefore the silk acquired extra electrons, so it became negatively charged, and the glass rod lost electrons, therefore it became positively charged. So you can find out similar examples when you rub a polythene with a wool. So there also you can see the transfer of electrons taking place between the two, and the objects get electrically charged. Thank you. Please visit www.examfear.com to watch more educational videos with a better experience. Please do not forget to like and subscribe to our YouTube channel for latest updates. Thank you once again.